How you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world. Today, we're going to be talking about volume, okay? So, volume. Before we talked about volume, last week and the prior weeks, we were talking about area. And to find the area, we were finding the area of a two-dimensional shape, okay? Now, for volume, it's going to be a little bit different. It's going to be a little more complicated, but not. Okay, so for this video, for this lesson, we're going to talk about the area of something. So I got this right here, and I want everybody to go ahead and take a look at this. Ignore the pictures of this. I want you to look at this and tell me what this is. Yes, sir.
Rectangular prism.
Rectangular prism. Okay, very good. What else? What else do we call this thing? What is it? 3D shape? Parallelogram? Yeah? Vertical. What is it? What do we call this? A box. Okay? I now said yes, but you didn't ever raise your hand again. That's okay. So yeah, this is a box. So a rectangular prism is always gonna be in this type of shape, kinda. Okay? It's always gonna look kind of like a box. Anything that simulates a box or a container of some sort in this very much shape, like also if you think about maybe a pool, how many gallons of water can you put into a pool? That's volume. Okay, so the pools, usually traditional pools, they're just rectangular, right? So now somebody said the correct name for this shape. What was the correct name over here?
Rectangular prism.
Rectangular prism. And why do we call this a rectangular prism?
Because it's rectangle.
What is a rectangle? What is rectangular? What is it? 4 sides. I have 1, 2, 3, 4. It's actually 6 sides.
It has vertical
Okay.
angles and the economic.
Vertical angles, kind of, yeah. So let's talk a little more about this. So we call this a rectangular prism because the name of the base is if I look at it, and if I set this like this, it's sitting on its base, right? It's not gonna fall from here because it's sitting on its base. Now when I look at the base, what shape is this base? We're just looking at this right here.
Rectangle.
It's a rectangle. That's why it's called a rectangular prism. If this was a circle, then it would have been called a cylinder.
No sphere.
No, that's a ball. Sphere is a ball. If this is a triangle, which we will talk about in other shapes, it will be called a triangular prism. The name of the prism is going to be determined by the shape of this base. Now, can I also have it like this and call the bottom a base?
Yes.
Definitely. On rectangular prisms, it really doesn't matter which one you want to pick to be the base. Now, we have faces, like every single one of these sides is a face, okay? But we also, 2 of those, whenever we're talking about prism, every prism has 2 bases. So if I set it like this, and I pick this one to be my base, right here on the bottom, I have another one. Where is it?
On top.
Right here. Now look at this right here. These 2, my hands cannot touch because they're parallel to each other. They are never gonna touch. So I have one base over here and another same, ignore the pictures, but the same size, same length, same width, same base, same height.
Yes.
Same thing over here. So I have these 2, I have 2 bases. Now when we talk about pyramids, that's a different story. But every prism has 2 bases. Any questions so far? Yes, sir. Alright, so let me go ahead and open up the worksheet so you guys can see what I'm talking about. Put names on formulas and everything that we need to talk about. And let's go right to that. So let's see. Volume of rectangular and triangular prisms. Today we're just gonna focus on rectangular. We'll do a separate one on triangular prisms. So we just talked about the box. We learned about the box a lot. So let's go ahead and talk about this. We have formulas. We have formulas right here for area and for volume. But you don't worry about those because over here first we're going to fill out some notes. Area. Area is the number of square units needed to cover a 2D shape. For example, if you have a piece of paper, rectangular piece of paper, you have base and height or length and width, right? That's how you find the area. It's flat. It's a two-dimensional shape. So the units are squared. So if these are inches, it'll be inches squared. Correct?
Yes, sir.
Now, a prism, however, like when I show you the box, somebody said it's a what?
3D shape.
3D shape. So a prism is a 3D shape with at least two parallel congruent faces called bases. Again, base, base. They're parallel. And what does congruent mean? Yes.
I'm gonna guess the same size.
The same everything. Same size,
Hooray!
same angle, same everything. So congruent means the same. Didn't we talk about that when I was displaying the picture of the box? Yes, we did. So a rectangular prism is a 3D figure with two parallel congruent. Now, what shape were the bases on the box? What shape are they? Rectangle. That's why it's called a rectangular prism. So rectangular. Bases. And then it says a cube, a 3D figure where all bases have the same measurement. So if we think about a Rubik's Cube, if we look at any side, it's going to look exactly the same, except for the colors, of course, but it's going to be the exact same dimensions on any side, correct? So that's called a cube. You could say a square prism, kinda, because a square prism will be like a square base, but the other faces will be longer. So a cube specific for all 6 sides, exactly the same. Now, the volume of a 3D figure is the measure of a space that it occupies. For example, how many gallons of water can you put in a pool, right? How many fluid ounces can you put in a bottle of water? That's volume, okay? The volume is whatever you can put inside. Not the outside, not the area, but inside, okay? So let's see, we have a few formulas over here. Basically, this is the same as this, so ignore this. But I want you to look at this formula and these formulas right here and tell me, what do you see that is the same and what do you see that is different? Yes, sir. B and H. On which one? So both of them have B and both of them have H? Very good. What else do we see? What else can we notice? A fraction, okay, that's the formula for the area. So on the left side, we have the area formulas for triangles, and rectangulars or parallelograms. And then on the middle, right here on the right side, we have V, that stands for volume, equals BH. Now, you said I have B and H on all of it, right? Now, what else do we notice about that, though? Anything different? Anything similar? The B is capitalized. That's a very good point. So this right here is capitalized, but over here is not. Right? So since they're capitalized, one of them is capitalized, that means they must be different. And they are. So the uppercase B is completely different to the lowercase b. Okay? Now, what about the H? Is the H any different? Not necessarily, but this H right here, this one is different than this one. They are going to be different. The H on the volume is different than than the H on the area. And we're going to go over all that in the next few minutes. Okay, so stay tuned. So now, uppercase B, since we said we have a capital capital B, that must mean something, right? And we have a line in there that we're going to fill in. So uppercase B stands for area of the base. That's why we have these formulas right here. So that means that whenever we look at the shape, like the box, we're going to have to find the base and put the area where the uppercase B is at. And then the H, the yellow H, this is going to be the height of the prism. And this is going to be different than the blue H on the area, okay? This volume is different than area. And I'm going to show you a method that is going to help you identify everything, okay? So if we look, I'm only going to do one for the sake of this video to not make it too long. But let me show you something right here. We have this, looks like the box that I showed you at the beginning of the video, right? So we have three numbers in here. We have 10, 6, and 6. Now, if I want to find the base, when I look at the box, what numbers will go with the base?
No.
It could, but the ones that I talked about the box, they were what?
10.
They were on the sides, were they? And I flipped the box. So on the box, I call this to be the base. Let me go ahead and highlight this. So this right here, I call this to be my base. Right? So what I want you to do every single time for every prism is identify the base and shade it. Remember, there's always going to be two of them and they do not touch. They never touch. So now, what I want to do is draw this shape. Even though it looks sideways, I can tell that this is a square. Can you tell this is a square?
Yes, sir.
Why?
Because it has 4 sides.
It has 4 sides and everything is
Even.
6, right? So that's how I know it's a square. So this must be a square prism. This is not a cube. This is a square prism.
Hey, stop copying, dude.
So I'm going to draw this right here, the base on the side. And I'm going to put the numbers that go with that. In this case, it's 6, and 6. So at this point, I want you to ignore the prism altogether. Okay? And I want you to only look at the base that you drew on the side. And what we're going to do is we're going to find the uppercase B.
Okay. Yes, sir.
So the uppercase B was the area of the base. Come on. The uppercase B is the area of the base. And this is square. So it's just going to be area equals base times height. Correct? Which is just going to be, notice, this H right here, I'm only focusing right here. So this is my base and this is the height. Wouldn't you agree?
Yes.
But that's only for the area. This is the different H than the H from the volume. So this is just going to be 6 times 6, which equals 36. So my uppercase B is 36 units squared. They're squared because they're area. Okay?
Okay.
So now we can go back to the prism and we're going to look back at it. Okay? We're going to look at it again. And we're going to do something real quick. We're going to cross out the numbers that I already used. What numbers did I already use? 6 and 6. Cross them out. We don't need them anymore because we already worked with them. So now we're going to have to write the formula for volume, which is going to be right here. V equals uppercase B times the height. Now this height is going to be the distance between the two bases. So if I look over here, I have one base over here in the back, one base over here on the side, and the distance between these two, that's the height of the prism. This is the H on the volume formula right here. Okay? So now I already found uppercase B. So all I have to do is substitute the values that I know. I know uppercase B is 36. And I'm going to multiply by the height of the prism, which I found to be
10.
the only number that we haven't used, which is 10. Very good. And when we multiply these two, we get a total of
360.
360. So the volume is 360 units, not square, but cube.
Oh.
3 dimensions, that's why it's cube. That's why we put a little 3 on top. Any questions so far?
Sir.
I said I was just going to do one, but I'm going to go over the one on the right side, which is this what? What is this called? A cube.
Liar.
A cube. How do I know it's a cube? Because everything is the same, right? So to find the volume again, first find the base. That is the same as this. In this one, it really doesn't matter which one you pick because they're all the same. But remember, they have to be parallel.
Yes.
So I'm going to pick that. I'm going to draw this on the side, and I'm going to find the area for that. So this is 5, and this is 5. So uppercase B is just area, which is base times height, which is 5 times 5, which equals 25 units squared. Correct?
Yes, sir.
All right, so when I come back over here, I'm going to cross out the 5 that I use and the other 5 that I use. So now I'm going to do the volume, which is uppercase B times the height. And the only number that I have not used is the distance between the two bases, which is going to be my H. So I'm going to do this right here goes right here. So this is going to be 25 times the other 5, which is a total of
125. Yes.
units cube. Now, again, I know it's tedious, but if you do this, draw the base on the side, you will not make a mistake, especially when we're doing triangles, because it's going to be a little more complicated. Now, is there a faster way to find just the volume?
Yes.
Absolutely.
Yes.
So if you wanted to just find the volume, like right real quick, and I know I'm asking you to show all your work, but if you want to just find the volume, whenever you're testing, that's a different story, right? So to find the volume, all you have to do is literally multiply the 3 numbers. 6 times 6
36.
times 10.
306.
Isn't that what we got? We got 6 times 6 right there. And then times 10. All we did was multiply 3 numbers right here. And that's the answer. So again over here, 5 times 5, 25 times 5, 125. And that's really all there is for volume of rectangular prisms. I hope that you guys learned something today. If you did, give it a thumbs up, subscribe, turn that notification bell on, and
Let's ride. Let's ride. Let's ride, dude.